All right, for this part of the lesson, we're going to look at one more operation with functions, and that is composition. So composing functions, big element of algebra, and then beyond with calculus, there's a lot of times you talk about composing functions. Again, I think this is something you may have seen. We'll talk about a little bit of misconception we see, and then also the new or maybe unfamiliar notation. So what you often see as the notation for function compositions is this f parentheses g parentheses x, read f of g of x. What we often again see a little later in algebra is what I call it the fog notation. It's f circle g, and my equation editor is a little funny where it puts the circle up a little higher. Down here I have it a little lower, f circle g. But that means the same thing. Most common misconception that I see here is people think of it as multiplication. So they think, oh, this means take the f times the g. But what you want to notice is that these are nested parentheses. It's not open, close, it's open, open, close, close. So one's inside the other. And what it means is you work inside out. So first you find the value of the inner function. You take that result and then plug it into the outer function. So we'll start with just a set of points here. So we've got two functions defined as points. So f is saying when you plug 1 in for x, you get 5 for y. 2 in for x, you get 3 for y. 3 in for x, you get -1 for y. We got a second function over here, g, and that one when you plug 1 in for x, you get 3 for y. 2 in for x, you get -6 for y, and 3 in for x, you get 5 for y. So if we're trying to find f of g of x, which is written this way, and that x is 1, so f of g of 1, you may be a little more familiar with f parentheses g open parentheses of 1. So we find g of 1 first. That means what do I get when I plug 1 into the g function? Well, I go over to g, and I find where's x equal to 1? Right there. So when x is equal to 1, y is equal to 3. So I can replace g of 1 with a 3. Now I'm trying to evaluate f of 3. So I come over to the f function, and I find when is x 3 right there? When x is 3, y is -1. So the final answer is -1. So you're doing multiple layers to it. You're not multiplying, you're working inside out. So what if we got actual formulas or functions? I got 3 down here. These are the 3 that we looked at with addition, subtraction, division, multiplication a little bit. With these, we may compose them again just numerically. So for example, maybe I'll find g of f of 4, which again could be written as g circle f of 4. I've seen it written without parentheses on the outside. Often it's grouped together with parentheses. So again, we work inside out, so don't go necessarily left to right. So f of 4. That means go to the f function, plug a 4 in. The square root of 4 is 2, and 2 times 2 is 4. So like when you plug 4 in, you get 4 out. So that means now we're finding g of 4. So we go to the g function, we plug a 4 in there. 4 squared is 16, minus 1 is 15. We can actually generate an entirely new function this way, because we can actually just say something like g of f of x. Wow, what does that mean? Because there's no number. It's a lot easier if there's a 3, a 1, a 2, a 4. What we do now is we take the entire f of x function, which is 2 root x, and we're going to plug it into the other one. So I take the 2 root x, and I replace it for the x. We're given a brand new x that's that whole other function. So what we would do is we'd say in place of x, I'm taking 2 root x, I'm squaring it, and I'm subtracting 1. So you see it has that format of x squared minus 1, something squared minus 1, but we replace the something. Now we simplify. So since the 2 root x is attached to one another, I can square. So 2 squared is 4. Root x squared is actually just x, and it would be 4x minus 1. Now what's kind of nifty is you can check the answer from before this way, because remember when we said g of f of 4, and we got 15 as the answer? Well, we just generated the formula that should work all the time for this. So we can plug a 4 in for x. 4 times 4 is 16, minus 1 is 15. So that's kind of verifying our answer from before. Real quick, what if we had, say, h of g of x? Well, that means take the g of x, plug it in where the x is in the h. So it's going to look like 2x squared plus 3, but the x gets replaced with the entire other function. Now maybe we're content to stop there. Like we can say, okay, that looks good. We've got a formula for that new function. Often we like to get rid of parentheses though. So that x squared minus 1 squared means you've got to take x squared minus 1 times another x squared minus 1. You've got to distribute that and FOIL it. You can't just bring in a squared when you've got addition or subtraction between your terms. So you can check your work on that, but when we FOIL that out, we would get x to the 4th minus 2x squared plus 1. Then there's the plus 3 over here, and that's all parenthesized because it's multiplied by the 2. Distribute the 2, 2x to the 4th minus 4x squared plus 2 plus 3. Add the 2 and 3 together to get 5, so we have 2x to the 4th minus 4x squared plus 5 is the composition, or some people say just the composite of those two functions. Now one more application of this with formulas. If we look at area here, so we got a equals pi r squared, you might recognize that is the area of a circle. But sometimes we have diameter. So if I gave you a circle and I said the diameter is 10, find the area. Well, most people know the area formula in terms of radius. So you would sort of do a two-step mental process. And the first one you wouldn't think much about. If the diameter is 10, you would just say, okay, that means the radius is 5. Then you'd plug it into your pi r squared formula. You'd say pi times 5 squared is equal to 25 pi, whatever that may be in decimal form, square units. What we can do though is we can actually generate a brand new formula, and it's the same idea. So if we know area is pi r squared and radius is diameter divided by 2, I can make a substitution. That's really all you're doing when you're finding a composite of two functions. So I have pi, I can replace the r with d over 2 squared. We can leave it like that, although we usually like to get rid of parentheses. So it'd be pi times d squared over 2 squared, which would be just pi times d squared over 4. Right there is an alternate formula for the area of a circle using diameter instead of radius. And there we're using the composition of two functions.